Hi everybody, welcome back. We're now going to use this idea of division of polynomials and I think make some connections that are amazing, although they may not seem so at first glance. So I ask you to just keep your ears peeled and try to think about the way that these observations connect different elements of what we're learning, different stuff about polynomials. So we're now going to look at what happens when we divide a polynomial by something that looks like this, x minus c. Now this is like c is supposed to be a number, so this might be x minus 5 or x minus 7. You might have a x minus a negative, so that would make it a plus in the middle. That's okay. So you could have x plus 3, that would be like x minus minus 3, x plus 12, x plus 7.2, x minus any real number. And the reason that we do this is the following. We divide by x minus c because that tells us something interesting about what happens at the function when we plug the number c into the function. This fact is called the remainder theorem. And what does it say? It says, when you divide a polynomial by this x minus c, the result is just a number, and that number, the remainder, is exactly what you get when you plug c into your function. So this is a little strange. We're talking here about messing around with the formula, like dividing this thing by this thing using this long division process. Whereas here we're just talking about plugging a number into the function and getting one answer out. And it turns out that what you get as the result of this division is just exactly equal to what you get as a result of... Okay. Let's go ahead and see something. Oh, maybe one more thing to be said about this. When we divide a function by something like this x minus c, if we get a remainder of 0 here, then that means that f of c is equal to 0. Getting a remainder of 0 means there's no remainder when we divide, and that means that this x minus c is a factor of this. Getting a 0 here says that when we plug the number c into our function, we have a root or a 0 of our function. And what this says is that when you divide and you get no remainder, when it goes in evenly, or when it's a factor of your function, that is exactly at the same places where when you plug in that number c, you get 0. Okay, that's called the factor theorem, and it kind of goes along with the remainder theorem. So this is the factor. The factor theorem says the following. It says... oh boy. Okay. It says that x minus c is a factor of f of x exactly when f of c equals 0. That is to say, when c is a 0. Of f of x. And what's interesting about this is if you have a polynomial and you want to know, is this thing a factor of your polynomial? Yeah. Well, one thing you can do is plug the number c in. If you get 0, then that is definitely a factor of your polynomial. And that's like magic. That's like without having to do any factoring work at all, you have determined that this thing, x minus c, is a factor of your polynomial. Okay, so let's try to put this into practice. We're going to look at a few examples, or at one example with a few parts. A, find the remainder of dividing this function f of x equal x squared plus 3x plus 2 by x minus 3. So look, there's two ways to do this, two methods. Okay. One method is certainly to do the long division. It's x squared plus 3x plus 2, and it's x minus 3. And we can do the long division and look for the remainder, figure out what it is. Well, but, so that was method 1. I'm going to skip that because I'm going to do the easier method. What the remainder theorem says is that we can find this thing, the remainder, if we're dividing by something of the form x minus c, then we can find the remainder by simply plugging the number c into our function f. In this case, what is c equal to? Well, it's x minus c, and this is x minus 3, so the c is 3. If we plug that in to our function f of 3, well, just substituting in, it's x squared plus 3x plus 2, so it's 3 squared plus 3 times 3 plus 2, which is 9 plus 9 plus 2, which is equal to 20. Now, what the remainder theorem says is that when you plug the number c into a polynomial, the answer you get is exactly the same answer that you get if you do this division and you look for the remainder. That will also be 20. So what do I have? I have a conclusion. The remainder is r equal 20. And we're done. That's part A. Okay, let's take a look at B. Determine whether g of x equal x plus 3 is a factor of f of x equal x to the 4 plus 4x cubed plus x squared plus 18. Now, one thing that we could try to do is we could take this x to the 4 plus 4x cubed plus x squared plus 18, and we could try to factor out x plus 3. Write it as x plus 3 times something, dot, dot, dot. Okay, but this is a tricky factory. This is not just factoring a quadratic. This is factoring something of degree 4, and it's not at all obvious what the heck would go in here, if anything would go in here. And so you could maybe make some guesses and see if you could come up with it. But this doesn't seem like this is going to be a useful method in general. However, what we have is this nice fact, which is that that x plus 3 will be a factor of this. That is, we'll be able to factor it out exactly if when we plug in the corresponding number c, we get 0. Yeah? So let's take a look at what is the corresponding number c. This one is, we are considering x plus 3. And so c, in this case, is equal to negative 3. X plus 3, if you want to look at that of the form x minus something, it has to be x minus a minus 3. Or another way to say it is that the number c always has the opposite sign of the number at the end here. So c is negative 3. Now we can find the remainder, r, by plugging in. If we were to divide this by x plus 3, we would get a remainder of some kind, maybe 0, maybe something else. We can find that remainder, according to the remainder theorem, by plugging the number in. So this is f of negative 3. And so to do that, we just have to substitute into our function f the negative 3 here, and then evaluate it. So this is negative 3 to the 4th power plus 4 times negative 3 cubed plus negative 3 squared plus 18. And this one, I encourage you to plug this into a calculator or do some such. I will go ahead and work it out. This was 9 times 9 plus 4 times 27 plus 9 plus 18, which is equal to, let me see, this is 81 plus 4 times 27 plus 27, which is equal to 81 plus, I'm going to do this arithmetic in the following slightly tricky way. I'm going to factor 27 out of those two. This is 27 times 4 plus 1, which is 81 plus 27 times 5. 27 times 5, I'll do that in my head by doing 27 times 10, that's 270, and then dividing it by 2. Half of 270 is 135. So this is 81 plus 135. And 81 plus 135 is 216, if I've done that correctly. Now, what is this 216? This is the remainder r. This says, according to the remainder theorem, that if you were to divide x to the 4 plus 4x cubed plus x squared plus 18 by x plus 3, you would have a remainder of 216. Because you have a remainder that's not 0, it means that this is not a factor of this. It doesn't go in evenly. So the answer to part B said, determine whether it's a factor. The answer is no. X plus 3 is not a factor of our polynomial x to the 4 plus 4x cubed plus x squared plus 18. Okay, that's B. Let's take a look at C. Show that 5 is a root of this thing, and use this to factor f completely. Okay, so for part C, show that the number, let's call that root c. c equal 5 is a root of, and the polynomial there is x cubed minus 19x minus 30. And then factor this thing completely. Okay. So first of all, we can test whether it's a root. Check if c equal 5 is a root. And we can do that by plugging it in. When we plug in 5, we will see whether the thing is 0, and that will tell us whether the number 5 is a root. And if 5 is a root, then it means that x minus 5 is a factor. So check if 5 is a root. Let's do it. We will take our function f and plug in 5. So this is 5 cubed minus 19x minus 30. This is 125. Oh, I'm sorry. That's really, I said 19x, but it's really 19 times 5 since we're plugging in. So times 5. 19 times 5, 19 times 10 is 190, half of which is 95. So this is 125 minus 95 minus 30, and that all adds up to 0. What that says to me is that, yes, c equal 5 is a root of f of x equal x cubed minus 19x minus 30. Now, so what? If we have a root of this, that says, by the factor theorem above, it says, so x minus c, so that's x minus 5, is a factor of f of x. Okay, it means that when we're going to factor this thing, we can factor out an x minus 5, and we'll get some nice thing left over there. So how do we do it? How do we figure out how to rewrite this as x minus 5 times something? We're going to do it by doing long division. So let us go ahead and divide x minus 5 into... Now, just beware when you write this thing down, it's important that every power of x is represented. And here there's an x cubed. There's a missing term, which is x squared. So we think of that as 0x squared, and then 19x and minus 30. So we will write this as follows: x cubed plus 0x squared minus 19x minus 30. And now we're going to go through the process. So we do x into x cubed. It goes in, let me see, x squared times. We do x squared times x minus 5, and that gets us x cubed minus 5x squared. We make the whole thing negative. Remember, this is going to make this x cubed negative, and it's going to make this 5x squared positive. And then we add with the guy on top. So this x cubed minus x cubed is 0. 0x squared plus 5x squared is plus 5x squared. All right, we're done with that step. So now we bring down that minus 19x. And we carry out the process again. X minus 5 goes into the x, goes into the 5x squared. What's the result on top is going to be 5x. We take that 5x and multiply it by x minus 5. So we have a 5x squared minus 25x. We make it negative, and remember that that negative is going to make the 5x squared negative, and that 25x, since it's negative, is going to make it positive. So we're going to have 5x squared minus 5x squared is 0. Minus 19x plus 25x is plus 6x. We're now done with that step, so we bring down our last term, which is minus 30, 6x minus 30, and now we do the process again. So we take that x and go into 6x. It goes in 6 times, so plus 6. Then we take that 6 and we multiply it by the x minus 5, 6x minus 30. Then we subtract, and when you subtract, it's going to make that 6x a negative 6x, and it's going to make that 30 a positive 30. And so when we do 6x minus 6x, we get 0, and minus 30 plus 30 is 0, and that means that our remainder, r, is equal to 0. So what? So this tells us that we can write the original polynomial as equal to the quotient, that's this guy, times our divisor, plus our remainder, and plus the remainder is 0, which means we don't have a remainder there. So what do we get? We get that x cubed minus 19x minus 30 is equal to x squared plus 5x plus 6 times x minus 5 plus r, which is plus 0, and we can get rid of that plus 0 since it doesn't do anything to our answer. Okay, this is pretty good. What we've managed to do so far is factor this thing from a cubic into a quadratic times a linear term. It said factor completely, and so what we're going to want to do is keep factoring it if we can. Can we factor this guy right here? So let's go ahead and try. This whole thing is going to be equal to, here I'm just going to try to factor the first part, that x squared plus 5x plus 6, and then I'm going to keep that x minus 5 there at the end. I just brought that down. Okay, for x squared plus 5x plus 6, this is factoring a quadratic. That's something you guys have done before. We put an x here and an x here, and then we're looking for two numbers that, when you multiply them, give you 6, but when you add them, give you 5. And those two numbers are 2 and 3. So x plus 2, x plus 3. And then don't forget that x minus 5 we're going to bring down. And what this says is that x cubed minus 19x minus 30, we can factor it completely as x plus 2, x plus 3, x minus 5. All right, that's it, guys. Go ahead, give the homework a try, and see if you can wrestle with some of these problems on your own.